Right, so Mr. Cabrera here again. Just to continue on our last video, before I was abruptly cut, we were looking at this system here and we were calculating the clockwise moment or the clockwise turning effect and the anti-clockwise moment or the anti-clockwise turning effect. And we discovered by calculation that the anti-clockwise moment was equal to 200 Newton meters, as well as the clockwise moment was the same, 200 Newton meters. Now this is a very special situation where the moments, the anti-clockwise and clockwise moments are the same. As a result of that, this system will balance. This system is said to be in what we call equilibrium, where the turning effect on both sides are equal and the system will balance, right? So in this case, when this system balances, we say that the principle of moments has been satisfied. And what is the principle of moments? The principle of moments states that for a system that is in equilibrium, the sum of the clockwise moments is equal to the sum of the anti-clockwise moment about the same turning point, right? In this case, that holds true and the system will balance, okay? So let's say that again. The principle of moments states that the sum of the clockwise moments or anti-clockwise moments is equal to the sum of the anti-clockwise moments, right? And about that same turning point. So whenever a system is in equilibrium, we can be certain that the anti-clockwise and clockwise moments, or the clockwise and anti-clockwise moments, are equal. The turning effect on both sides in both directions, clockwise and anti-clockwise, is equal. All right. Now, in this situation here, we just have simply two forces. But in real life, this does not always happen. What generally happens is that there are a number of forces, and each one of these forces will cause its own separate amount of turning effect or moment, right? Each one of these forces will have their own moments or turning effect, right? So let's look at the case here where we have three forces, A, B, and C, acting on this uniform plank here and pivoted at this point. So if you notice, I looked at the individual distances away from the pivot. So A happens to be 1.5 meters away from the pivot. B happens to be 1.01 meter away from the pivot. C happens to be 2 meters away from the pivot. Okay? And our job here is to calculate the moments, all the clockwise moments and the anti-clockwise moments. First of all, A and B will provide clockwise clockwise moments. As you can see here, A and B provides clockwise moments, whereas C provides an anti-clockwise moment. All right. So basically, what's happening here? Let's look at the anti-clockwise moment first. Of course, moment is force by distance, and C is providing that anti-clockwise moment. So it's the force of 300 newtons multiplied by the distance away from the pivot, which is 2 meters, and that gives us 600 Newton meters. In the case of A and B, we have to treat A and B separately because each one of these forces will provide their own turning effect or moment. As a result, A, force by distance, it's 200 newtons multiplied by 1.5 meters gives us 300 Newton meters. B, on the other hand, it's 300 newtons multiplied by 1 meter, and as a result, 300 Newton meters, giving us a total clockwise moment of 600 Newton meters. So the clockwise moments amount to 600 Newton meters, and the anti-clockwise moment amounts to 600 Newton meters. In this case, the sum of the anti-clockwise is equal to the sum of the clockwise. And we know from the principle of moments, in this specific condition, the system is in equilibrium. So one of the very important conditions for equilibrium to take place is that the clockwise moments must be equal to the anti-clockwise moments and vice versa. Okay, so that's actually one of the first conditions for equilibrium. In the next video, I will address the two conditions for equilibrium, and then we will proceed to answer an actual CSEC question, right, where we will identify the forces and write equations, right, using both the conditions for equilibrium that I'm about to discuss in the next video. So I'll see you in the next video.